you need to be able to find missing sides on similar shapes. Can you do this even if it's finding the missing side on a smaller shape? Can you do it if it's a tricky scale factor? Well, let's have a look at some examples to make sure we can. So first thing, this is always true of any pair of similar shapes. And this helps us to find any missing sides. So let's have a look at our first example. So these are two rectangles. So if they're rectangles, then the angles are all equal, so that doesn't affect it too much. But what we do know is that corresponding sides are in the same ratio. We can look at this side's the shorter side on the small rectangle, and this side's the shorter side on the large. So these two are in the same ratio as the two longer sides. So what does that mean? Well, it helps us to draw a table and use a multiplier. Reminder that similar shapes and their sides, they're in a multiplicative relationship, so we multiply and divide them, no adding or subtracting. So we put the smaller one on that side, the larger one that corresponds to it there. We need to find what's our multiplier. Now hopefully you can see this is 3 times as much as this. However, if you're not sure, you do need to be able to say, well, we're going to 21 and we're dividing by 7. And if you're not sure, you can always use your calculator. It gives you 3, gives you the scale factor. So we want to find this missing side here, so it's in the same scale factor, the same ratio. So if we put 11 on the left hand side, 7's the small, so 11 goes on the small as well. These are the lengths for the large. To get from here to here, we use that multiplier. So our answer is let's look at another one. Okay, so here we've got two triangles. So let's first check corresponding angles. So we can see that's a right angle and that's a right angle. None of the others are right angles, so they are the corresponding angles there. How about the sides? Does this side correspond to this side or this side? Well, the hypotenuse is always the longest side on a right angle triangle. But what of the other? Well, this one's the shorter of those two. Tell just by looking. And so on this one's longer than this side. So the 6 corresponds to the B and the 20 to the C. Right, now we're happy with that, then we can look for a corresponding pair of sides. And so of course the two hypotenuse, we've got the value for both of them, so we've got a corresponding pair where we know both their lengths. So I'll draw the table and put in the corresponding pair that we know first. So we'll start with the smaller one and the larger. What's a multiplier? You might be able to spot it straight away. But if you're not sure, you do the larger one divided by the smaller one. So our multiplier is 2.5. So going from the smaller to the larger, see, we know 6, we want to find out B. So 6 is in the smaller triangle and we want to get to B. So we use our multiplier, we're going that way. 6 times 2.5 . There's our first answer. We found one of the missing sides. Secondly, we want to find C. Now C is on the smaller triangle, and the corresponding side, that needs to go then on the right of the table. We want to go work from the right to the left. We're not going this way, we're going the opposite way. Do the opposite function. And our answer is 8. Quick check. Is 8, does it look right? It's longer than 6. It's shorter than the hypotenuse. Yeah, that sounds about right. Okay, one more example. EG3. So, we've got two triangles again. And first step is to work out which are the corresponding sides. This triangle and this there, they are similar, but this has been rotated, so we need to think. So the hypotenuse here, that's the side opposite the right angle. Here we are, the longest side opposite right angle. So 32 goes with a D. What are the other two sides? Well, our 5, that's the shortest side. And so of these two, this is the shortest side. So 5 and 13 are corresponding. So that's our pair that we need to start off with to help us find the multiplier. What's a multiplier? You're going to be doing quite well to work that out in your head. So let's do 13 divided by 5, and that's 2.6. Right, we're working from the small to the big. Let's see. On the small, we've used the 5. What does the 8 pair up with? It's this side here, the E. So let's find out E first. 8 multiplied by 2.6 gives us 20.8. Let's just double check. It's smaller than 32, it's larger than 13. So that's about what we expect. Then our last side, D. So D is the hypotenuse. Hypotenuse on the large triangle. It's the large triangle, so we'll put it on the right, working backwards. So we're doing the opposite. That is 12.3. So double check. 12.3. It's larger than 8. So yes, it's about what we want.